Hey everybody, welcome back. In this video series, I am building a 3D SimCity clone using Three.js. So if you've been following the series, you'll probably notice that things are looking quite a bit different. We no longer have our hideous blue, yellow, and green blocks. We actually have some real buildings now. So I've been hard at work making some improvements to this, as I said I would last time. So we made some UI overhauls, some major overhauls to the graphics. We now have textures on our buildings. So I've made a whole bunch of changes, and I'm going to run through all of those in this video. And the format of this video is going to be a little bit different than my last videos. Up until now, I've been showing you every single line of code, and I've kind of typed that out in real time. So with these latest changes, there's just really too much for me to go through and kind of replay line by line. I just don't think that's very interesting for you guys. So I'm going to run through things at a bit higher level. I'm going to try and focus on the more interesting aspects of what I did rather than all the mundane code. So to make up for not typing out all the code line by line, I'm going to link the GitHub repository for this code in the description below. So be sure to check that out. So I'm going to start by talking about some of the improvements that I made to the scene. And probably the first thing that you can notice is that there's now shadows. So let's talk a bit about how that's done in Three.js. So let's go back to the code here. Let me close these files out, and we're going to go look at our scene. So I'll kind of start from the top, and we'll go down into the details. On our renderer, so this is kind of the main thing that renders our 3D scene. There's two new lines that I added. Renderer.shadowMap.enabled equals true. And then I'm also setting the type of the shadow map. So there's several different types of shadow maps that you can choose from. I believe the default is PCF. So we can find it, PCF shadow map. I opted for the soft shadow map to give it a little bit higher graphical quality. So those are the first two lines that you'll need to add. Now the next thing that changed is how I set up the lights. So I no longer have an array of directional lights. I just have one directional light I'm kind of referring to as the sun. And then we also have an ambient light on the scene. So everything that's in shadow, we want to make sure that there's still some light there. It's not totally pitch black. So the ambient light helps fill out the dark areas and makes the shadows not quite so intense. So how this works is we set the position of our light per usual. And this also sets the direction. The important line here is setting cast shadow to true. So this will allow this light to cast dynamic shadows. And, obviously this is kind of an expensive operation to cast shadows. So that's why I only have one single light source here. These next four lines set the bounds of where the shadow is calculated. And the best way to illustrate what this is doing here, I've pulled up the Three.js documentation for directional light shadow. So this is actually what I've followed to get shadows set up in my scene. So if you have a Three.js scene you want to add shadows to, highly recommend coming to this documentation here. But at the very bottom of this sample code, they have a line here where you create a new camera helper, and you pass in an argument to that, and you pass in the camera that's attached to the shadow. So we can use this to help visualize our light and where the shadows are being calculated. So I'm just going to add this to the scene here, and I need to call this sun instead of light. Now let's go back and look at our city, and you can see that there's now this box surrounding the game map. So if I pan around here, I'll zoom out a bit more. So this is the 3D box, like a rectangular prism within which shadows are calculated. So if I set the left, the right, the top, and the bottom, if I'm looking at this box kind of head on like this, this is the top here, the bottom here, the left here, the right here. So it's setting the extents of where that shadow is being calculated. So I had to tweak this a bit to make sure that the entire game map was encapsulated in this box. So if I were to go into here, and let's say I set this to 2, so you can come back and see that my box is now much narrower. So I'll lay a bunch of zones down. And as these start popping up, you can see that it's only calculating shadows that are within this box. So everything outside of the box, shadows are not being calculated for. So when you're setting up shadows in your scene, it's good to have this helper attached to the scene to see where that box is and make sure it's the right size. So I'm going to revert these values and delete that. The width and the height of our map size on the shadow controls the quality. So this is by default, I think it's 512. I set it to 1024 to give a bit higher quality. I'll set it to something really low, and we should have some kind of jaggy, gross looking shadows. You can already see there's some artifacting here. The shadows are much blurrier than they were when I had it set to 1024. So this is a good way to tune performance. If you're on a lower end machine, you can lower down the resolution of your shadow map, and that should help improve performance. And the near and the far plane for the shadow camera, if the left, right, top, and bottom, they kind of control the width and the height of that box, the near and the far plane control the depth of that box. So I'm just making sure that this encapsulates my entire map. So that's it as far as lights go. I know there's a lot of parameters here, but they're all pretty straightforward, and there's good documentation on them. So let's go and look at our assets now, because we need to make some tweaks to the meshes for our buildings to make sure that they actually cast shadows and receive shadows. So I've made a lot of changes here. I'm going to get into these changes later, but let's just look at these shadow specific properties right now. So we can see that on my mesh, and this is the mesh for my residential, commercial, and industrial buildings. We're calling this function. I've set cast shadow and receive shadow to true. So this means that if a light hits my building, it will cast a shadow onto the scene if this is set to true. And if receive shadow is set to true, then that building can receive shadows cast by other buildings. So just to play around with this, I'll set receive shadow to false. Lay a bunch of buildings down. And you can see that all of these buildings here are not receiving the shadows being cast by the buildings in front of them. So we definitely want to make sure that's set to true, otherwise it just doesn't look realistic. So that's everything in terms of shadows. So the next topic I wanted to talk about is the textures for our buildings. So let's zoom in here. I'll lay down some residential buildings, some commercial, throw some industrial in back. So there's a few things that we can notice immediately. So my residential buildings, they have a bunch of different textures that they're drawing from. The same can be said for the commercial and industrial buildings as well. So I found a texture pack. And here's a preview image of the entire package. So these textures are a bit dated, and these aren't going to be the final buildings in my game, but I thought they added some nice realism, and they work really well as some placeholder textures so that our city is actually looking like a city now and not just some boring colored blocks. The majority of this code for the texturing is contained within this assets file. I've pulled in all of the textures and put them in my public folder. So you can see all of the different textures here. I even have a little grass texture. So, our grass has kind of some variation to it now. It's not just flat green. So I pulled in all of these textures, and then in my assets file, first thing I did was create a texture loader. So this is responsible for loading those textures from the files. So this load texture function, this uses the texture loader, loads the image at the specified URL. And I set up these two lines for the texture repeating. So as the building scales in height, it will repeat that texture over and over again. The next thing I did was create a texture library. So this is very similar to what we did with our assets, or meshes, I should say. So for each texture in the game, I just load that once, and that way we can reuse these textures and we don't have to load it every time we're creating a new building that's using that texture. So this loads all of them into memory. So once we have a texture, the next thing that we need to do is to create a material. So I have two functions here for creating materials. So the top material is for the top and bottom of the building. So I didn't want to put these like windows on the top of the building. That would just look kind of funny. So I just put a flat gray material on top of each building. I want each side of the building to be wrapped with the actual building texture. So this function gets that flat gray material. And this function here, you pass in the name of the texture that you want. So that's going to be commercial 1, commercial 2, commercial 3, industrial, etc. So that will get the texture from the texture library. So this is an object, so you can just reference these by the keys, and it'll get that texture. And then we call clone on the texture. So this creates a new texture object, but it reuses the image in memory. So this is a really efficient way of reusing these textures. And the reason that we need to clone them is to make sure that we're getting unique instances of our textures for each building. All right, so we've loaded our textures. We have a way to create our materials. Now we need to apply those to our buildings. So for the residential, commercial, and industrial buildings, you can see that they each call this function create zone mesh. So what they do is they get the name of the texture. So this takes the type of that zone, which would be residential, industrial, or commercial, and then it appends the style. So the type and style properties on our building object are used to determine which texture gets rendered for that building. So going back to our assets file, we create the texture name, then we create our materials. So I'm just getting that gray material for the top, then I'm getting the material that I want to display on the side of the building. And this next bit here is pretty interesting. So the standard cube in Three.js, so I'm defining this at the top here. This is just our box geometry. What you can do is when you're passing in the materials for the cube, when you're creating the mesh, you can actually pass in a material array. And this allows you to assign a unique material to each side of that cube. So for the plus x, plus z, minus z, those are the sides of my building. I'm assigning the side material. And for the top and bottom of the building, I'm assigning the top material. The bottom of the building obviously is never seen, but we need to assign it some material or it'll error out. So I create the mesh, use my cube geometry in my material array, and then we get a result that looks like this. So as far as rendering improvements, that is really it. So I want to get into the UI and UX improvements that I made. So you can see that the buildings are now a bit more styled. Added some transparency in here, some kind of highlight effects as I hover over them. And I've also added 3 new things in the UI. So I now have a select here. So if I click on a building, you can see the X and Y coordinates of that building, the type of terrain that it's sitting on, what type of building it is, which style, the height. It's kind of a simple thing right now, but it's a great debugging tool just to see what the building data is for each building. I also added a pause button. So if I lay down a whole bunch of zones, they'll start building out. I can hit the pause button and you can see the growth stops. Then I can hit resume and everything picks up again. So this allows me to kind of stop, check things out if there's something maybe not right that I want to look at. And it's also a basic functionality that we're going to need in the game. So as I said, I made some pretty significant changes to the code. I kind of refactored things to make a bit more sense. So a lot of our input handling used to be inside of the scene itself. But really, I want a single responsibility for my scene class. And that is going to be, handling the rendering and interacting with the 3D elements of the scene. So what I did was lift all of the input up to the game. So the game is really the thing that interfaces between the HTML document and our 3D scene and our data model. So you can see now on the scene, I have, or excuse me, on the game object, I now have the on mouse down function. I have on mouse move, and it's handling all the different tool selection. I have different functions for, if it's the bulldoze tool or I'm placing a building. So I've expanded this out quite a bit. So this game object is now sort of the manager of sorts for the entire game. For our on mouse down function, if I click and it's a left mouse button click, then I'm going to ask the scene, hey, can you get the object that I may have selected? So in my scene, let's look at the get selected object class, or let's look at the get selected object function. So this is using the same raycaster code that I showed in a previous video. I believe it was video 5. So we compute the intersection between the mouse coordinates and the scene, and then we look for an object and then return the selected object. Otherwise, we return null. Let's return back to this function here. And then we use whatever the active tool is on that object. So if I go to my use active tool function right here, if there's no object selected, I clear the info panel. If there is an object selected, then I figure out what tile the user clicked on, and then I go and perform the action for whatever tool was selected. So everything here is code that we already had. The only difference is this additional tool here, the select tool. So if we select an object in the scene, we want to set the active object in the scene. So this is controlling whether that object is highlighted or not. And then we're updating the info panel. So I find the info panel element in my HTML document, and then I just stringify the data for our tile and display that in that element. So I'll quickly go and show you what our HTML document looks like now. So we still have the same buttons as before. I've added in the select button here. The pause button is down here. And here is the HTML code for the info panel. So it's just a div inside of a div. So really nothing complicated here. So one more method that I want to show you is the on mouse move method right here. So the on mouse down handles the clicking. And for on mouse move, one thing that's worth noting is this line here. One change that I made to the UI, let me refresh here. I know you can't really see this, but I'm holding my left mouse button down and I can drag and place buildings. Before I had to click each building at a time, and that was really annoying. It took forever. So I wanted to be able to hold my mouse button down and just lay down roads and buildings. But anyway, back to this part here, I found out that when I was moving my mouse around, the performance was just atrocious. Like everything was slowing down really bad. So I did a little research and I realized that this function is being called many times per second. I really don't need it called that often. I don't need it called any faster than the frame rate of the scene. So I can see that this actually isn't even working because I'm not resetting last move. So just a little real-time debugging. Sorry about that. So maybe this isn't really needed. But I did find performance was an issue at some point, so I think the throttling is still helpful. So now if the time since the last mouse move event is within 1/60th of a second, then just cancel the event. Otherwise, we'll reset move to now, and then it'll kind of go through the cycle again. So we can see that the mouse movement's still working. So I think that does help a bit with keeping things smooth. I've also added some kind of highlighting hover effects. This would help you guys kind of see my mouse cursor a little bit better. So I'm highlighting the object that the mouse is currently over. And I'm doing that by calling get selected object again on my scene. So I get the object that the mouse was hovering over. And then I call the set highlighted object on my scene. So basically, if object is not null and it's not the currently selected object, then I'm clearing the highlight of the last object, updating the currently hovered object, and then setting that emission value to give it that highlighted color. And then finally, I'm calling the on-mouse move event on my camera, and that actually causes the camera to move around as the mouse is moving around. And one of the other minor changes I made, I renamed scene.camera to camera manager. If you remember in our code before, we had scene.camera.camera to access the Three.js camera object. That's really confusing. So renaming that to camera manager made that code look a little more sane. All right, so I know that was kind of a speed run through all of the code. So I'd be really interested to know in the comments if you guys kind of prefer this format where, I go off and make some changes and then I come back and kind of walk through the changes at a high level. Or if you prefer the more step-by-step tutorial style, where I kind of go through and write out the code line by line. I think with this approach, I'm able to, kind of get a lot more done. I'm able to show you a lot more in each video. Whereas in the old approach, I'd have to go and write out all the code, and then I'd have to figure out how to kind of replay that code step by step in the video. So it's a bit harder to record those videos as well, but I'm making these videos for you guys, so I want to do whatever provides the most value for you. So please let me know in the comments. In the next video, now that we have kind of all the interactive elements in place, we can lay buildings down. We finally have some buildings that look like real buildings. We have textures, we have shadows. I think it's time to actually add some real logic into our city and start coming up with a model for how our city is going to grow over time. What's the interplay between the residential, the commercial, the industrial zones? Let's add in some power plants, police stations, being able to model crime. So I'm going to start tackling some of those more kind of interesting problems that I think a lot of you are kind of wanting to see. So that'll be the focus for the next video. And yeah, I'll just kind of keep taking this as far as I can. We'll see where it goes. So if you're enjoying this video series, please be sure to hit the like and subscribe buttons below. I appreciate all the love so far. I'm glad, those of you that have commented and are enjoying it, really glad to hear that. So until next time, take care, everyone.